Here's a little homework help for Unit 7, Lesson 4, dividing powers of 10. Very first thing we start out with is 10 to the 0 power. Let's remember what that actually looks like if we were to expand this. 10 to the 0 power, remember that every single number has a common factor of 1, and then we're multiplying that by 10 0 times. That means I can't write a 10 right here. So what we need to remember is that in other circumstances, when we say like 10 to the second power, that's equal to 1 times 10 times 10, right? We're multiplying 1 times 10 twice, but we're not doing that in this case. So we can always remember that anything raised to the 0 power is always equal to 1. Don't forget that. We know this. Another reason that we know this is because when we divide anything by itself, we get simply 1. We can see that in the next example here, 10 to the third power divided by 10 to the third power. We could spend all this time saying 10 times 10 times 10 divided by 10 times 10 times 10, and then sit there and go back through it and say, oh, okay, 10 divided by 10 is 1, and 10 divided by 10 is 1, 10 divided by 10 is 1, and just multiply those to give us 1. Or we could just recognize that 10 to the third is the exact same as 10 to the third, and we can divide that out to figure out what that solution would be. In the next problem, be super careful here because, well, we're being a little tricky. See these little symbols right here? Whoops. This one and this one. Notice that those values say plus, so we need to carefully think about what is 10 to the second power. That would be 100. And then we would add that to the next one, 10 to the first power, and 10 to the first power, or 10 to the 0 power. So I want you to be really careful with that one and pay attention to what you're doing with that and figure out what we go in here in place of 10 to the first power, what's that worth? And then replace 10 to the 0 power, what's that one worth? Be really careful with that piece. Looking at the next one, write the expression as a single power of 10. Okay, order of operations applies here. We need to simplify in the numerator before we actually divide. So we want to take care of the numerator first, 10 to the third power times 10 to the fourth power. And then we can divide all that by 10 to the fifth power. Okay, either expand it all the way out like this, or think about what does this top one mean. That's the same thing as taking two bases that have, or two powers that have the same base, and we're multiplying them together. So I can simply add those together and then work on the division piece that's going to give us a value of 10 to the something power. Pay close attention up there because I see 7 on top and 5 on the bottom. Think about those values. The next one, it might be a little helpful to compare these together if they're both as fractions. So my recommendation to you is do this as 10 to the fourth power divided by 1 times 10 to the 12th power divided by 10 to the 7th power. Another way to think about that would just be to multiply the top number or the numerators together and then the denominators together. And then we end up with a situation very similar to the one we were just in before. Combine or work on the top terms, the numerator, to simplify it first before you divide, and then give us a 10 to whatever power it is. This next one incorporates the power of a power. This is one that we actually call a power of a quotient. So the reason for that is because we expect to do the work inside of the parentheses first and then work on the power. So the quotient comes from simplifying the 10 to the fifth power first, divided by 10 to the third power, which gives us, so this is step 1, which gives us 10 to the second power. And then after that, that's when we take the 10 to the second power. Whoops, that didn't turn out so good. That's when we take the 10 to the second power and we raise it to the fourth power. So be really careful with that. Make sure that you remember what we talked about in the previous lesson. that this means 10 to the second times 10 to the second times 10 to the second, right? It gets a little repetitive. Times 10 to the second. How many times am I actually multiplying 10 by itself? And then we get just yet a little more complicated, but in actuality, it's still the same thing we've been doing up above with all the other ones. Simplify the numerator first, 10 to the fourth times 10 to the fifth times 10 to the sixth, and then divide by 10 to the third times 10 to the seventh. So simplify all down to one power, whatever it is, and then all to one power, and then do your subtraction of the powers, because we have two powers that have the same base. We're mixing it up again a little bit, putting a little bit of a power in here. So remember what we do with these. The numerator, first thing, 10 to the fifth power raised to the second power is just multiplication. So I'll help you out with the numerator here. You end up with 10 to the 10th power, and then what would that be on the bottom? 10 to the what power would be taken from that piece. And then here you've got a little bit of a word problem to finish it out. So the sun is roughly 10 to the second power times as wide as the earth. The star, KW Sagittarius, is roughly 10 to the fifth times as wide as the earth. How many times as wide as the sun is KW Sagittarius? So we've got this piece that we have to recognize is how many times as wide. There's those four words that I've been talking about paying attention to. Really have to pay attention to those four words and say, I'm comparing our sun, and I want to figure out how many times bigger is this sun in a different system than our sun. So remember that all of our lesson has been focused on division. So we should be looking at this as saying that really big sun compared to our sun, not quite as big. How many times bigger is Sagittarius than our sun? And then give me a good explanation of how you know. And I believe wraps it up for this homework. So let me know if there's anything else that I can do for you. Thanks for tuning in and working hard. Have a great day.